Hello dear students, we shall discuss a topic from Module 6 of Embedded System. For today's discussion, we will see one of the important operating system service, that is memory management. So, what is a memory management? Memory management, it is a process of controlling and coordinating computer memory, assigning portions called blocks to various running programs to optimize overall system performance. Let me say once again, memory management is nothing but the process of controlling and coordinating computer memory, assigning portions called blocks to various running programs to optimize overall system performance. That's what the memory management. Now we will see the memory management in detail. When a process is created, the operating system memory manager allocates addresses to it by mapping the process address space. Let me say once again, when a process is created, the operating system memory manager allocates addresses to it by mapping the process address space. So, the threads of a process share the memory space of the process. Threads of a process share the memory space of the process. So, what exactly a thread? Thread is nothing but an executional unit. Thread is an executional unit. That is, it is a part of a process. So, a process can have many threads. We have seen the threads in detail in the earlier classes. So, I can say once again, thread is an executional unit, that is a part of the process, and a process can have many number of threads. It is essential that the memory manager of the operating system should be secure, robust and well protected. The OS manager, that means the operating system manager, should have the control over memory leaks and stack overflow. The operating system manager should have the control over memory leaks and stack overflow. That is, no memory leaks and stack overflow. So, there should not be any memory leaks or no stack overflow. So, what we'll see what is it mean by memory leaks and stack overflow. Memory leaks means attempts to write into the memory block not allocated to a process. We say once again, memory leaks means that attempts to write into a memory block not allocated to a process. Attempting to write into a memory block which is not allocated to a process. That's what we call known by memory leaks. Now, stack overflow. Stack overflow will occur when the stacks exceeds the allocated memory blocks. Stack overflow will occur when the stacks exceeds the allocated memory blocks. Next, we will see the memory management function in an operating system. They are allocation and deallocation, fixed blocks allocation, dynamic blocks allocation, memory protection to the operating system functions, memory protection among the tasks, multiprocessor memory allocation. Let me say once again, there are 6 memory allocation related functions. They are allocation and deallocation, fixed block allocation, dynamic block allocation, memory protection to the operating system function, memory protection among the task, multiprocessor memory allocation. So these are the 6 important memory related functions. Now we'll see the first memory allocation related function, that is allocation and deallocation. Allocation and deallocation function is used for memory allocation and deallocation and its management. So this function is used for memory allocation and deallocation and its management. It also restricts the memory access region for a task. This allocation and deallocation restrict the memory access region for a task. We have two different functions for memory allocation. One is fixed block allocation and the other one is dynamic memory allocation. We have two different functions for memory allocation. One is the fixed block allocation and the other one is dynamic memory allocation. In fixed block allocation, the memory address space is divided into blocks. In fixed block allocation, the memory address space is divided into blocks. Processes requiring small address spaces allocated a lesser number of blocks. Processes requiring small address spaces allocated a lesser number of blocks. And the processes requiring larger address spaces allocated a larger number of memory blocks. But in dynamic blocks allocation, the memory manager allocates variable size blocks in the units of 64,256, 1024, 2048 or 4096 bytes. That is, dynamic allocation is from an unused list of memory blocks. A description table maintains unused block information at different computational phases of a process. In one way, dynamic memory allocation has more advantages than fixed block allocation. So I can say once again, in dynamic memory allocation, the memory manager allocates variable size blocks in the units of 64,256 or 1024 or 2048 or 4096 bytes. So these are the variable size blocks in dynamic blocks. In dynamic allocation is a form of unused list of memory blocks. So we are using a description table. The description table maintains unused block information at different computational phase. So we can conclude that dynamic memory allocation has more advantages than fixed block allocation. Dynamic allocation prevents the wastage. Why we are saying it is more advantageous than fixed? In dynamic memory allocation prevents the wastage of memory. This is because when we use static memory allocation or fixed block allocation, a lot of memory is wasted because all the memory allocated cannot be utilized. RTOS may disable dynamic allocation. This is because it increases the latency of servicing the task and ISR. RTOS may disable dynamic allocation. Why it is so? It is because it increases the latency of servicing the task and ISR. Now the next memory management function, it is memory protection to the operating system. Memory protection to the OS functions. Operating system functions, code, data and stack are in the protected memory area. Once again, this operating system functions, code, data and stack are in the protected memory area. When user function call attempt to write or read in the memory space allocated to the OS function, it is blocked and system generates error. This is because the memory of the kernel function is distinct and can be addressed only by the system calls. Let me say once again, this memory protection to the OS function, code, data and stack are in the protected memory area. When user function call attempt to write or read in the memory space allocated to the OS function, it is blocked and the system generates an error. This is because the memory of the kernel function is distinct and can be addressed only by the system call, not by the user call. Next one is memory protection among the task. It means that a task function call cannot attempt to write or read in the exclusive area of memory space allocated to another task. Let me say once again, this task function, memory protection among the task function means that a task function call cannot attempt to write or read in the exclusive area of memory space allocated to another task. The sixth point, multiprocessor memory allocation. It means that allocation either shared with tight coupling between two or more processors or shared with loose coupling or multi-segmented allocations. We say once again, multiprocessor memory allocation means that allocation either shared with tight coupling between the two or more processors or shared with loose coupling or multi-segmented allocation. So that's all regarding the memory segmentation. So I hope you understood one of the operating system service, that is memory management. Thank you. In the next section video lecture, we'll see the device management. Thank you.